All right, we left off recognizing this pattern for quadratic functions. The derivative of 11x squared is 22x because we can just do 2 times 11 is 22. And this didn't come from nowhere. We did some work using limits, and we worked all the way through the limit definition to come up with a few of these. And then we started to notice this pattern. Derivative of 3x squared is just 6x. Derivative of 4x squared is 8x. So then we applied that pattern to other quadratics. So the question is there something similar for cubics, like x cubed, okay? So is there a way for us to determine the derivative of any cubic function like this, okay? So to figure this out, we need to use limits and start to examine different examples before we can come up with a pattern. So if you look at these 3 limits, the question is, what do these 3 limits represent? Before proceeding in the video, you should try to think for yourself what these represent. And now I will tell you that these are just the instantaneous slope of x cubed at these different x values, x equals 1, x equals 2, and x equals 4, right? This is f of x minus f of c over x minus c, okay, for 3 different points. And we're trying to figure out these 3 so that we can come up with a pattern. So the question is, how do we evaluate a limit like this? And it's a little bit tougher than when dealing with quadratics because it involves us having to factor x cubed minus 8. X cubed minus 8. Okay, so to do this, we have to use this, this tool called synthetic division. And I wasn't ready to skip ahead to that answer yet. But what we have to do is we have to write x cubed minus 8 as x cubed plus 0x squared plus 0x minus 8, because that's going to allow this synthetic division method to work. And this is going to allow us to factor x cubed minus 8. So the first step of synthetic division is that 2 is the number we're working with that we're plugging into the function, because 2 is what we're plugging in to get 0, right? 2 cubed minus 8 equals 0. And this thing with polynomials is if you can plug in an x value and get 0, that means that the factor causing that 0 must be able to get factored out. So there must be a way to write x cubed minus 8 as x minus 2 times something. And we know that because plugging in 2 causes a 0, right? So in the synthetic division, we're going to put that x value up here. The one causing the 0 is up here. And then we just list the coefficients of the polynomial, which is 1x cubed, 0x squared, 0x minus 8. Now, synthetic division is kind of like waving a magic wand and getting an answer, and I don't always like that, but for our purposes, we just need to know how to crank out synthetic division for questions like x cubed minus 8. So we're going to go through it kind of quickly. So you may remember that the first step is to just drop the first number down. Okay, so this is just going to be 1. Okay, and then the next step is to do 2 times 1. This number 2, this is 1. We're going to do 2 times 1, and we get 2. Okay, and then we are going to add these 2 numbers together, 0 and 2. So that's going to give us 2. Okay, then we're going to do 2 times this number, 2 times 2, which is 4. So we get 4. And then once again, we're going to do 0 plus 4, which is just going to give us 4. And then we are happy if this next step ends up giving us 0. So we have 2 times 4 is 8. And then it turns out that negative 8 plus 8 is 0, which means that we have factored this thing successfully. We have found a good factor of it. And so then the next thing you need to recognize is that these numbers we have left over are just the coefficients of our other factor. And they're going to start with 1 degree lower than what we started with because we factored out an x, right? So if we factor out an x from x cubed, we're left with x squared. So this is 1x squared plus 2x plus 4. So that's what we get when we synthetically divide. So then this 1x squared plus 2x plus 4 is our other factor of x cubed minus 8. So x cubed minus 8 factors in this way, x minus 2 times x squared plus 2x plus 4. And the reason we're happy with that now is because now we can do this limit. We factored x cubed minus 8 as x minus 2 times x squared plus 2x plus 4. And now the x minus 2's cancel, and we're just left with x squared plus 2x plus 4. And now we can plug our limit in, and we get 2 squared plus 2 times 2 plus 4, which is 12. So the slope of x cubed at x equals 2 is just 12. You can try to do these two independently. Pause the video because in a second I will put up the work for how to evaluate these limits using synthetic division. So this first one, we're plugging in x equals 1. We're trying to write x cubed minus 1 as x minus 1 times something. X minus 1 times something. We're not sure what that something is. So we're going to synthetically divide first by dropping this 1 down. And then 1 times 1 is just 1. And then 1 times 1 is 1. Or 0 plus 1 is 1. Okay. And then 1 times 1 is 1 again. Right? And 0 plus 1 is 1 again. And then 1 times 1 is 1 again. And negative 1 plus 1 is now 0. So that's good. Okay. So what we're left with is 1x squared plus x plus 1. Okay. So what we can do is we can rewrite this as x minus 1. Let's try again. So we have x minus 1 times x squared plus x plus 1 over x minus 1. The x minus 1's cancel. So now when we plug in 1, what do we get? We get 1 squared plus 1, which equals 3. So the instantaneous slope of x cubed at x equals 1 is just equal to 3. So now we can do a similar process for x cubed minus 64. I'll do it down here. So we have 4 is the thing we're plugging in that's causing 0. We have 1x cubed plus 0x squared plus 0x minus 64. Okay, start by dropping the 1 down. 4 times 1 is 4. 0 plus 4 is 4. 4 times 4 is 16. 0 plus 16 is 16. 4 times 16 is 64. Okay, good news, that's 0. So we have 1x squared plus 4x plus 16. So this can be rewritten as x minus 4, that's what we factored out, times x squared plus 16x plus 64. And that's over x minus 4. Okay, the x minus 4 is canceled. So then what do we get? We get 4 squared is 16. Or sorry, 4 squared is 16. Yeah, I'm realizing the problem here, why I was unhappy, is I wrote this wrong. It was x squared plus 4x plus 16x, or plus 16. So it's x squared plus 4x plus 16. All right, there we go. Because now we get what we want, which is 4 squared is 16. 4 times 4 is also 16, and then we're adding 16, so our final slope is 48. Okay, so we now have 3 answers to reference, and I'm just going to go ahead and give you more so we can start to look for a pattern. So here, okay, what is the instantaneous slope at x equals 1? We found that to be x equals 3. At x equals 2, it turns out it's 12. 3, it's 27. 4, it's 48. 5, it's 75. You may actually be able to come up with a pattern if you look at this long enough and try to determine what it is for x equals 6. And I'll just tell you what it is for x equals 6. It ends up being 108 is the slope. And what you may notice is there are perfect squares in here. Just there are multiples of perfect squares. Okay, 3 is 3 times 1. 12 is 3 times 4. 27 is 3 times 9. 48 is 3 times 16. This is 3 times 25. And then this is 3 times 36. Okay, it's 3 times 1 squared. It's 3 times 2 squared. 3 times 3 squared. 3 times 4 squared. 3 times 5 squared. And 3 times 6 squared. So this seems like a pretty clear pattern, and we want to prove it. So what we have to do is we have to work with the limit definition for x cubed. Okay, remember for x squared, this is what we did. We plugged in x plus h, simplified it all the way down to 2x plus h. H is 0, so the derivative of x squared is 2x. So what about for x cubed? Well, we have f of x, x plus h cubed, minus x cubed over h. So the first step of this is expanding out x plus h cubed. We already know how to expand out x plus h squared. That's x squared plus 2xh plus h squared. So now we have to multiply in x plus h. And it turns out to be pretty annoying because we have to make sure we multiply each piece by each piece. So we do this box, x squared plus 2xh plus h squared. Here's x plus h. So what's x times x squared? That's x cubed. X times 2xh is 2x squared h. X times h squared is just x times h squared. H times x squared is just h times x squared. Okay, this is 2x squared, and this is h times h squared, which is h cubed. Okay, this ends up being nice because there's some like terms we can combine. X squared h plus 2x squared h, right? Okay, x squared h plus 2x squared h is just going to give us 3x squared h. 3x squared h. And then 2xh squared plus xh squared is going to give us 3xh squared. And then we have x cubed and h cubed. So let's go down and see if anything cancels. Okay, here's our original limit. We just multiplied x plus h cubed out. We have x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed. Okay, well, this is good news because we have an x cubed that's going to cancel, right? X cubes cancel. Okay, and then just like before, we can factor out an h, so we get 3x squared plus 3xh plus h squared, right? And this h is going to cancel with the h on bottom, and we're just left with 3x squared plus 3xh plus h squared, all right? But remember, h is approaching 0, so these go away, and we're just left with f prime x is 3x squared. So if we look at our examples, yeah, once again, if f prime x is 3x squared, then f prime 1 is 3 squared. F prime 2 is 3 times 2 squared, 3 times 3 squared, 3 times 4 squared, 3 times 5 squared. That's how we represented this using limits before, and now we can just plug in any x value we want, and it will give us the slope of x cubed at that x value. All right, and it turns out to be the same for more cubic examples. X cubed is 3x squared. 4x cubed is 3 times 4 is 12x squared. 7x cubed is 3 times 7, 21x squared. Okay, and that will work for all cubic examples. So you can just try one real quick. What is the derivative of 5x cubed? Okay, f prime x is going to be 15x squared. Okay, that's it. So you should probably go back through the slides again because this was a lot. It was heavy. It was confusing. Okay, maybe take a break and then work on your problem set. If you didn't have time to finish the card sort from class yesterday, then you should also finish that up for credit as well. And then if you have all the math you can possibly do done, you can treat the rest of the period as a study hall.